Hi there, and welcome to this lesson. And this lesson we'll be learning about quadratic equations, okay? And under quadratic equations, we'll be learning the completing the square method, okay? And in the last lesson, we were discussing quadratic equations, and I introduced you to the factorization method, okay? And today we'll be learning about a different method for solving quadratic equations, and that is the completing the square method. Okay, so at this point, I'd remind you to set the video to play in 1080p HD. You can do so via the settings icon on the bottom right. And as the lesson progresses, if you have any issues at all, or if anything comes off as unclear, please feel free to get in touch. Okay, you can do so via the course dashboard. Now, let's jump right into the lesson. So quadratic equations, the completing the square method. What is the completing the square method all about? Okay, um, basically, consider the expansion of the following algebraic expressions. Okay, so we have x plus 1 all squared, and basically when you have x plus 1 all squared, this is x plus 1 multiplying x plus 1. All right, and basically what it gives you is it gives you x squared plus 2x plus 1. What if we had x plus 2 all squared? It will give you x plus 2 multiplying x plus 2, and that is x squared plus 4x plus 4. Now, what if we had x plus 3 all squared? The answer will be x squared plus 6x plus 9. Okay, and if you have x plus 4 all squared, what you'd have is you'd have x squared plus 8x plus 16. Okay, now let's try and identify a pattern here. All right, now look at x plus 1 all squared and look at the result. The result is x squared plus 2x plus 1. Now something about the middle term is 2x. The coefficient there is 2. Okay, so we have 2x. Basically 2 equals 1 times 2. Okay, so we have x plus 1 all squared, and the middle term 2 is 1 times 2. What about the last term? The last term is 1 squared. It's 1. Okay, so x plus 1 gives you an expression where you have the middle term as 1 times 2 and the last term as 1 squared. Let's look at the next one. So we have x plus 2, and basically when we x plus 2 all squared, when we expand this out, it gives us x squared plus 4x plus 4. Now look at the expression you have there. You have the middle term as 4x and the last term as 4. Now you had x plus 2. When you multiply that 2 by 2, it gives you 4, the middle term. And when you square 2, it gives you 4, the last term. Let's look at 3. I think 3 would make it a lot clearer. Now, you have x plus 3 all squared. It gives us an expression x squared plus 6x plus 9. Now, when you multiply 3 by 2, you get 6. Okay? Your middle term, 6. 6x in this case. And then when you square 3, you have 9. Okay, so anytime if you do the same to 4, basically you multiply 4 by 2, you get 8. So 8x, your middle term, and then when you square 4, you get 16. So pretty much anytime you square an expression in this form, it would give you an answer x squared plus you multiply the number by 2 and you put an x behind it, so the coefficient is the number times 2, so you give an answer and then you square that number and it will give you your final term. And that is how you work expansions in this form. Now let's consider something else. Basically, if you have an expression x plus m all squared equals ax squared plus bx plus c, i.e. if you expand an expression as like x plus 1 all squared and it gives you a quadratic expression, you'd usually find that a is unity. A is always 1. Okay, so we have 1x squared is just x squared in the end. Okay, and then like what I just explained, you'd find that b is 2m, so the number in the bracket where you're expanding times 2. okay, and then you'd find that c is m squared, okay. And if x plus m all squared equals ax squared plus bx plus c, then ax squared plus bx plus c, the resulting expression is a perfect square quadratic expression, because basically you can actually find the square root of this quadratic expression. It's the square of something. It's a perfect square quadratic expression. Okay, now consider this quadratic expression. We have x squared plus 10x plus 5. Now, I want you to tell me, is this a perfect square quadratic expression? How do we find out? Basically, we know that if this were a perfect square quadratic equation, we'd have a number, and the middle term would be twice that number, okay? And then the last term would be that number squared, okay. Because based on our laws for perfect square quadratic expression, we usually get an expression where the middle term is twice a number, is 2 times a number, and then the last term is that number squared. So what you just need to check is the middle term in this case is 10, okay. So we divide 10 by 2, we have 5. So our number, the number we'll be considering would be 5. Okay, now check the last term. What is 5 squared? 5 squared is 25, and we have 25 there. So x squared plus 10x plus 25 is a perfect square, and basically this is x plus 5 squared, x plus 5 all squared. Okay, now what if we had another quadratic expression, x squared plus 10x plus 24, and basically this is obviously not a perfect square just from what we just did, because we know that if this were to be a perfect square, the number in the end would be 25, not 24, okay. But then we can also write this, if you will agree with me on this, as x squared plus x plus 5 all squared minus 1, okay, because basically this new expression is just 1 less than the perfect square expression, okay, i.e. if you subtract 1 from x squared plus 10x plus 25, you would get x squared plus 10x plus 24. And basically we know that x squared plus 10x plus 25 is x plus 5 all squared. We can say that x squared plus 10x plus 24 equals x plus 5 squared minus 1. Okay, now here's something else to consider. Now what if we had an expression like this? Okay, so we have x squared plus 6x plus 5, all right, and we want to, I'd like you to tell me, is this a perfect square expression? Basically you'd go 6 divided by 2, that will give you 3. So if this is a perfect square expression, the number you have on the end should be 3 squared, okay, and 3 squared is 9, all right. But in this case we actually have 5, so this is not a perfect square expression. Our perfect square expression in this case would be x squared plus 6x plus 9. Okay, and when you have an expression like this, here's what we call the correct expression. Okay, because this is not a perfect square expression, but related correct perfect square expression would be x squared plus 6x plus 9. And when you solve that out, that would give you x plus 3 all squared. Okay, but then we can relate that to this expression, and I can write this out as x plus 3 all squared minus 4. Okay, because when you square x plus 3, you have x plus 3 all squared. Basically when you have x plus 3 all squared, it will give you x squared plus 6x plus 9. Okay, and basically how does x squared plus 6x plus 5 relate to this perfect square expression? It's basically x plus 3 all squared minus 4. And this is the idea we apply to solving quadratic equations using the completing the square method. Okay, now let's actually work this using an example. All right, so example 1. And example 1 says, using the completing the square method, solve the quadratic equation x squared plus 6x plus 5 equals 0. Okay, we're applying the completing the square method. Now, so we have x squared plus 6x plus 5 equals 0. Now, the first thing we want to do is we want to find the relative square expression. Okay, and it's pretty much what we did in the last one. We explained the last and the last just a few moments ago. But then basically you have x squared plus 6x plus 5. Okay, and you divide that middle term by 2, you have 3. Okay, so our related square expression would be x plus 3 squared, and this is x squared plus 6x plus 9. Okay, because x squared plus 6x plus 5 is obviously not a square expression. But then what we do is we compare our expression, the expression that we have, to the actual square expression. Okay, and that will be in step 2. And basically you'd find that our expression is the square expression, i.e. X squared plus 6x plus 9 minus 4. Okay, because 9 minus 4 would give you our expression. Okay, so we basically have, what if we're writing our the quadratic equation we've been given to solve in terms of this perfect square expression, we'd have x squared plus 6x plus 9 minus 4 equals 0. Now we then factorize, or basically just reverse that perfect square expression. So basically we know that x squared plus 6x plus 9 is actually x plus 3 squared. So we write that out. Okay, and then the next thing we do is we move the minus 4 over to the right. So now we have x plus 3 all squared equals minus 4. What do we do next? We find the square root of both sides. Okay, so we have x plus 3 all squared equals 4. All right, you find the square root of x plus 3 all squared, it will give you x plus 3. Okay, so you have the square root cancelling the square, and then the square root of 4. What is the square root of 4? The square root of 4, normally we just say 2, but the square root of 4 is actually plus or minus 2. Okay, because basically if you have plus 2 times plus 2, it will give you 4. And if you have minus 2 times minus 2, i.e. minus 2 squared, it will still give you 4. So anytime we're finding the square root of any number, we pretty much end up with a number plus or minus. Okay, so the square root of 4 is actually either plus 2 or minus 2. So we have x plus 3 equals plus or minus 2. And this is now a very straightforward linear equation, and we can pretty much just solve this out. Okay, so we consider x plus 3 equals plus 2. Okay, it will tell us that x equals minus 1. All right, or we can do x plus 3 equals minus 2, and it will tell us that x equals minus 5. And that is how you solve a quadratic equation using the completing the square method. Okay, it's actually very simple. It's probably surprising to you that we arrived at an answer so quickly. You just need to take note of one very simple principle. It's the related perfect square expression. Okay, once you're able to identify the related perfect square expression, it's pretty much just regular algebra from that point on. Okay, so if you're given a quadratic expression, let's say x squared plus 6x plus 5, the first thing you need to do is to find the related square expression. Okay, because x squared plus 6x plus 5 is obviously not a square expression, because when you divide 6 by 2, you'd have 3, and once you square that 3, you'd have 9, and if it were a square expression, you'd have 6x plus 9. Okay, but then you relate what you have to what it should be. Okay, so we want it to be x squared plus 6x plus 9, but what we have, instead of 9 we have 5. It gives us x squared plus 6x plus 9 minus 4. Okay, we write it there as minus 4. Okay, and then we can extract the perfect square expression and write it out as x plus 3 all squared minus 4 equals 0. And from that point on, it's pretty much just basic math. Okay, so let's go for another example. Okay, now this example is a bit more complicated. okay, because we've been asked to use the completing the square method to solve the quadratic equation 2x squared plus 7x plus 3 equals 0. And something special about this, because we can't just dive into this question straight ahead, and basically there's something we need to do before we start solving. Because if you remember, I said for a perfect square expression, the first term, i.e. a, is always unity. A is always 1. So anytime you're working anything using the completing the square method, your a must be 1. And in this case, our a is 2 because we have 2x squared. Okay, so the first thing we need to do is we need to make that a 1. Okay, and how do we go about doing that? We simply divide the entire expression by 2. For example, if we had 3 on the end there, so let's say we had 3x squared instead of 2, we would divide the entire expression by 3. If we had 11x squared, we divide the entire expression by 11. Basically, we divide the whole thing just to ensure that that first term there is just x squared. Okay, so once we divide the whole thing by 2, would end up with this expression, and it usually introduces fractions to the quadratic equation. And you normally, when you have equations like this, if you're under exam conditions, right, I'd give you this advice. If you're under exam conditions and you have a quadratic equation like this, where the first term is not unity, if you're not told to, if it is not mandatory that you solve it using the completing the square method, I'd advise you solve it using another method. Because anytime you have something like this, okay, unless you're told to solve it using the completing the square method, okay, I'd advise you try using the factorization method anytime, because whenever you have an equation in this form, solving using the completing the square method usually introduces fractions, which could be somewhat uneasy sometimes. Okay, so let's jump right into it. However, now we have x squared plus 7 over 2x plus 3 over 2 equals 0. Okay, and basically this is obviously not a x squared plus 7 over 2x plus 3 over 2 is not a perfect square expression, because if you divide the middle term 7 over 2 by 2, you'd have 7 over 4. And if you square 7 over 4, what you'd end up with is you'd end up with 49 over 16. Okay, and we obviously do not have 49 over 16 on the end. However, basically, we have our related perfect square expression as x plus 7 over 4 all squared. Okay, and basically when we work this out, we have x squared plus 7 over 2x plus 49 over 16. This is our perfect square expression. Now the next thing we want to do is we want to relate this perfect square expression to what we actually have. Okay, so our perfect square expression is x squared plus 7 over 2x plus 49 over 16. But what we have is x squared plus 7 over 2x plus 3 over 2. Okay, so the difference is usually just in the last term. All right, and then if you write that out, you'd have x squared plus 7 over 2x plus 49 over 16 minus 25 over 16. Okay, notice that when you subtract, let's see, when you do 49 over 16 minus 25 over 16, you'd end up with 24 over 16. And when you divide that out, you'd actually end up with 3 over 2. Okay, so we've actually just written the expression we have in our equation, but in terms of the perfect square. Okay, now we can then write a perfect square as x plus 7 over 4 all squared minus 25 over 16, and then we move 25 over 16 to the other side. Okay, and then we find the square root of both sides. When we find the square root of both sides, we're going to continue over here. When we find the square root of both sides, we basically have the square cancelling the square root. We have x plus 7 over 4, and this would equal plus or minus the square root of 25 over 16 square root of 25 over 16. You find the square root of the numerator, gives you 5. The square root of the denominator gives you 4. And we always have, whenever you find the square root of anything, you always have plus or minus. Okay, and then you basically have a simple straightforward linear equation: x plus 7 over 4 equals plus or minus 5 over 4. And then the last step, for this step I really love this step because at this point you're pretty much done. So you have x plus 7 over 4 equals plus or minus 5 over 4. It tells you that x plus 7 over 4 equals plus 5 over 4, x equals minus 1 over 2, or x plus 7 over 4 equals minus 5 over 4, x equals minus 3. And that is how you solve a quadratic equation using the completing the square method. It's actually a very simple method. You just need to get one very simple principle. You just need to know what your perfect square, your related perfect square expression is. Okay, and then you compare the perfect square expression to the expression that you actually have, and once you've done that, it's pretty much just basic math from then on. Okay, so that's it for our lesson today, and bye for now. I'll be seeing you soon.